Programming in C. In this session of the series, we will be learning about user defined functions. I just want to recollect that in the previous module we have learned why functions are used in C language and what is its importance. In this session we will focus much on defining programmer based functions or programmer defined functions or user defined functions, and how the function definition can be done for user defined functions, and what is the importance of having the written values, and if there is no written value how it is going to be dealt with, and we will also see the corresponding examples. As we have learnt in the previous session, we will now focus more on user defined functions. So, user defined functions, we are supposed to define the function for our own way. So, the function definition syntax will be, the first value will be the return value type. It means that if at all if the function is going to return any value from its usage to the main function or to the function where the function call statement exists. The function name can be user defined. So, this function name would be defined based on or following the rules for defining an identifier. So, we have already defined we have already learned how to define an identifier in the previous sessions, by which it should go with that rules of the definition of identifier. Then the parameters list. So, whatever the values we want to pass it on to the function as input, we can make that list as parameter list. So, these are all going to be the arguments which are passed as input to the function from the calling function, and the return value or the return the value which is returned will be supplied to the function call as input. So, here what we can see, this includes two divisions which is called function header and function body. So, here the first statement of the function which is called function header. So, this is function header, and the task which is to be executed we would be giving inside the parenthesis, inside the curly braces. So, that we will call it as function body or body of the function, right. So, here we will now learn about arguments in detail. So, whatever the values we are enclosing within the parenthesis we call as arguments. The arguments in the function definition are called formal arguments or formal parameters. So, the function body will be using the formal parameters or arguments which are whose values are taken from the function call, and it is execute the block of statement having that input from the formal arguments. So, let us take an example. In this example, I would like to calculate the area of the circle by taking the radius as input. So, here in the main function we are declaring a variable called circum, which is to be given or which is to be supplied as a formal argument to the function. Before going on to the main function, let us focus on the user defined function. So, this is a user defined function for calculating the area of a circle. So, the task given to this function is to find the area of the circle. The input or the argument or the parameter which is passed on to the function, which is actually the radius of the circle. Now, this is actually called formal argument or formal parameter, right. So, the radius, using that radius value, it calculates the area of the circle by applying the formula pi r square. Pi value is here interpreted as 3.14 and r square is computed using r asterisk r equation, right. So, the return statement carries the area of the circle. Since the return value is going to be double data type, which is going to be a floating point value, the return type of the function is now given as double, which depends on the data type of the value which is passed to the function call statement. So, here we will come back to the main function. In the main function, we are declaring a variable of which is of double type, and also we are declaring one more variable of type again as area 1, which should also be defined as double, because the return type of the function is double. So, the return type or the return value should also be stored in a data type of the same type. So, I declare a variable area 1, which is equal to area is the function name, and we are passing the radius value as input to the function. So, this is what is the actual value we are going to operate on. Henceforth, this is named as actual parameter or actual argument. So, the actual argument radius value is passed on to the function, which is now named as formal argument, and the area is computed inside the function user defined function as a task, and we return the area value. Since area is going to be a double type, the return type of the user defined function should also be double. Since the return type of the function is double, the value or the variable which is going to store the result in the main function or in the calling function should also be double. So, area 1 should also be defined as double type. So, this is how the value of the actual parameter is passed on to the formal parameter. Actually, the value is copied. Here we are using the variable name as circum, and here we are using the variable name as double. This is actually interpreted as double type are equal to circum, in the sense that the value which is there in the circum variable is copied onto the variable r. In other words, the value of the actual argument is copied to the formal argument or formal parameter. So, this is what is about parameter passing. So, let us take another example to calculate the GCD of two numbers. So, here we need two values as input to be passed on to the function. So, the input to be passed on to the function we are passing through parameters or arguments. So, here I define the function GCD with the name GCD and two parameters. So, here you can see a parameter list. So, A and B. So, here one thing we are supposed to note that every variable or every parameter we pass on to the function has to be declared separately, in the sense that the data type should be specified for every parameters individually. Even though both the parameters are of integer type, we have to specify it as int A and int B separately. And what we do inside the function as body of the function, we are calculating the GCD of two given numbers A and B, right. So, what is going to be the result? The result is actually stored in the variable A. So, once the function is over or once that loop is over, we are returning the value which is stored in the variable A or the parameter A. Now, what is the data type of the parameter A? The data type of the parameter A is int. So, the return type should also be int. So, this is how the compiler will be able to identify that what is the value which is returned from the function should be of the same type, and it should be stored or it should be passed on to the other variable in the calling function, right. So, why do we need a return statement, or is the function without return statement, is it not possible? So, that we are supposed to learn. The return value should be assigned to a variable in the caller function. So, the function, if it has a return value, it should be invoked like this. It means that the result of this function invocation will have to be passed on to a variable in this case. So, this is the reason that if there is going to be a return value from the return statement, we need a variable to store its value in the caller function, right. What if there is no return value? It is okay if there is no return value, but the return statement should be given with a semicolon and the return type of it should be mentioned as void, right. We will see an example for that. So, this function without any return value. So, a function which prints if the number is divisible by 7 or not, okay, that is it. So, the task is carried out inside the function body itself. It means we are checking whether the number is divisible by 7 with the mod operator. If it is divisible by 7, we are displaying that it is divisible by 7, else we are displaying it is not divisible by 7. There is no need to carry the value from the function to the caller function. It means I do not want to return any value to the caller function. So, return is optional here, but it is a best practice to use the return statement always, even if it is there, even if it is no need to pass any value. However, the return data type should be mentioned as void. Okay. So, these two things a programmer should remember, that a function should always return a value. If does not return a value, at least it should have a return statement with semicolon, and correspondingly the return type should be mentioned as void. Fine. In case of a value returning function, okay, what are the things to be followed? The first thing is, if the function returns or does not return a value, it should be terminated with a return statement. The return statement gives the caller function an indicator that the function control has to be given back to the caller function with the or completing the return statement. That is one important thing that the return statement does. And a function can only return one value. This is more important thing to remember in C language, because the C functions allows us to pass n number of parameters within parenthesis, but it returns only one value. You can return only one value. So, whatever the value it returns, the return type of that function should be the data type of the value it returns. Okay. So, you may have a question that in case if we want to return more than one value, what we are supposed to do? It is possible, but for that we need to pass on a pointer as a return value. So, the pointer from the or the location address location, if it is returned as a return value, from there onwards the location can be tracked. Supposing if I want to return an array, then the base address of the array can be returned as a return value. The compiler will be able to then carry over the operations from that particular base address. So, this is one way that we can return more than one value. So, we should practice having the return statement as a pointer, right. So, here we will take one example. So, here we can see compute and print itax is a user defined function. So, this is a user defined function. Okay. So, from the function statement itself, we will be able to identify that it is not taking up any parameters as input and it is not taking up any return value. So, both are void. However, for indicating the compiler that if you are closing or the compilation of the function is over, we are indicating a return statement with just semicolon, even though if it is not returning any value. So, the first part of the function you can see that we are checking the income. If it is less than 50,000, the income tax is nil. So, then we are closing its execution, because the income can be verified only with one equality or with one selection statement. So, if income is less than 60,000, then we are making calculation on the income tax, and then we are again printing out the income tax value, we are returning or we are closing the function execution. Similarly, the next part also gets the income tax calculated and we are returning the return statement with no values. So, since all the components are returning or closing the execution without return values, the data type is void. We will take one more example with the return value and with argument. So, here the example is to calculate or convert the centigrade values of temperature to Fahrenheit. So, here we will be using the formula for calculating the or converting the centigrade way of representation of the temperature to Fahrenheit. So, what we are doing here? We are defining a function for conversion. So, this is a function for conversion which applies the formula of converting the centigrade to Fahrenheit by multiplying 9 by 5 plus 32. So, here I need to supply the input as centigrade representation and the output should be a Fahrenheit representation. So, the parameter passed, actual parameter of centigrade is passed on to the function and it is received as formal parameter as data. It means the copy of cent is given to data. Now, we are calculating or we are converting the centigrade representation to Fahrenheit representation and then we are returning the value result. We will check what is the data type of result. The data type of result is float. Henceforth, the data type or the return type of the function should also be float. Since the return type of the function is float, here we can see that the variable which receives the result should also be defined as float. If there is going to be mismatch in this flow, if there is going to be mismatch in this definition, it results in error, syntactic error. Okay. The data type of the data which is returned from the function should be carried over to the return data type of the function header and that should be reflected in the variable which receives the result and we can go ahead with the calling function. Right. Okay. So, this is what is a function full program of using or converting the centigrade representation to floating point Fahrenheit representation. So, in the right side we can see the results, it is of float type, the result is of float type. Then what is the need of function prototype? So, usually the traditional way of writing the functions is after the main function. So, if it is written after the main function, the compiler will not be able to understand that the function exists after the main, because the execution of the main function starts from its first statement and it goes ahead, but when it encounters a function name, the compiler has to understand that there is a function definition which exists after the main. So, in order to indicate the compiler, we are just giving the prototype. It means that function header statement ending with semicolon. We need not even give the variable names here, names also need not be given. It is enough that we indicate the compiler certain things, that what is the name of the function, what are the parameters, data type we are passing in and what is the type of the return value to identify that this is the function and there is a function definition which is given after the main. So, that is the reason for giving function prototype. Is the prototype, function prototype compulsory? It is not mandatory, because if the function definition itself is given before main, we can avoid even going for function prototypes. So, this is a tip that we can follow in case if you are defining the function definition before main, right. So, here we can see a program with function definition defined before the main function, right. If it is defined before main function, we need not go for the function prototype at all, but if the function definition is going to be given after the main, if this is going to be the case, then we are supposed to give the function header on top of or before the main function to indicate the compiler that there is a function definition of the same syntax follows the main function. So, that is a reason that we go for defining function prototype, right. Is there any way that we can define variables inside the function? Yes, of course, inside the function we can go for defining the variables. So, those variables are all called local variables. So, for example, according to the example given, result is defined inside the function, which is local to that function. It means that we can't use that variable outside the function scope. The result variable scope exists only within that function. Similarly, when it comes to the main function, we have defined two variables send and FAHR. The scope of the variable lies only within this function. When I say within this function, it is between the starting braces and closing braces. So, after this starting and closing braces, if you are trying to use the same variable names send and FAHR, which is not possible. So, it means that the local variables access will be within the function statement or within the function body only. So, a function can define its own local variables, the locals having meaning only within that function. So, each execution of the function uses a new set of locals. Local variables are ceased or it is closed when it exits the function. Okay. All the parameters are all local variables only. It means when I am using a formal parameter d whose scope lies only within the function. When we want to use it in the function, the other functions, we are supposed to use it in a different way. The scope can't be carried over to the other functions. Okay. Now, let us assume a main function which calls two functions NCR and NCR calls fact. Okay. We have two functions here, two user defined functions NCR and fact. The main function calls NCR, that in turn calls fact. So, this way of calling a function within another function is called nested functions. Okay. So, here we can see that the main function invokes NCR of n comma I, which passes two integer arguments. So, the NCR of int n comma r, it is received, the value of n is copied onto n, the value of I is copied onto r, because we go with the concept of passing on the value from actual argument to the formal argument, right. So, it returns fact of n by fact of r. So, here fact of n, it means it again invokes another function fact of n, which carries one integer input. So, here we are doing a task of calculating the factorial of a given value or a number, and then we return the result as using the variable name temp. So, the return type is mentioned to be int here. So, whatever the value it is returned, it is substituted over here and it again calls fact of r, fact of n minus r. So, every time it computes the factorial value and it returns to the NCR. So, NCR will use this factorial calculation for its own computation, and then the result of NCR is passed on back to its own calling function, which is actually the main function. So, this way of calling a function within another function is called handling nested functions. So, the scope of a variable every time within a function is local. In case if we want to make the scope of the variable to be common for all the function, we can declare this as a global variable. How to make a variable to be a global variable? It should be defined outside the main function. If it is defined outside the main function, that is common for all the functions. It means that could be accessible by all the functions, right. So, here we can see an example of defining a global variable. So, before main or outside the main function, I am declaring a variable a, and here we can see that there is a function my procedure, which also defines a variable with the same name a. If it is so, then it is overwriting the global variable, and now only the local variable's value will be retained. It means that it hides the global variable a, in case if the same name is used for global variable and local variable declaration, right. So, we will take one example to compute GCD of two numbers. So, here we are using the program without having a function. So, without having a function, if you see, it encounters n number of iterations using the while loop. So, this will be a difficult process for the compiler to handle, and it requires more memory space also for calculating the or for considering this without any functions. If the same program is divided into a function, the process will be very simple. So, within 4 statements we will be able to compute the GCD using a function. So, this is why we are using functions in order to reduce the load of execution of a compiler, also the memory space. Again, by dividing the functions into smaller modules or smaller functions will always help increasing the efficiency of the execution. So, in this session we have learnt about the elements of user defined functions. So, what it mean by an actual parameter, what it mean by a formal parameter, and how to handle the local and global variables under the scope of the variables. Also, we have learnt the examples which are used for understanding the concepts better. Thank you for listening to this session. Thank